to SGN Tech Forum. So today in this IoT fun series of video, we are going to watch or explore a very important component, right? So far we have seen a lot of sensors, LEDs, registers, soil moisture sensors, and so on. But they all senses a thing for you, right? Or a parameter for you. Based on what you sense, you want to take some action, right? No IoT project is complete without, when you send something, you have to take certain action, right? And that completes the automation loop. So far we have seen all the sensors. Now we will deep dive into actuators. And for any actuator, basically it translate your something into action, right? Like switching on and off a motor, or switching on and off a heater, or a or AC for you, right? So you need to actuate action, and for that we are going. That's what we are going to discuss here. And for that, the main or most important component is a relay, right? So this is, as you can see on my screen, this is a schematic diagram of how a relay looks like and what it takes to connect the relay to your Raspberry Pi, right? So as you can see here on the right side, we have the Raspberry Pi board. Then we have relay here, and finally we have a motor, right? So motor is actually getting connected to relay, and when relay, actually you can turn on and off relay based on some logic, and when you turn on the relay, the motor gets turned on. Okay, so basically what you can do, you can send something via sensor, and that sense input, actually you can input that on one of the GPIO input, and when then that GPIO input go high, it will short the connection on relay and motor will start. So that's a one simple example, right? So what we are going to do, we are going to understand the different pinout of relay and how to connect your motor or any other gear like a power supply to your sensor. So first let's check the specification available on Amazon. So as you can see on my screen, this is a 4-channel relay. That means you can actually connect 4 different type of motor or any other things to each individual relay. So each blue part of this blue part represent one relay, right? And as you can see, INI 1, INI 2, INI 3, INI 4, they all are represented by these blocks, big blocks, right? Here you can see a couple of pins. So we have ground, then we have from IN1 to IN4, and finally VCC. So ground and VCC, by now you know it's implicit, so it will connect to the ground and VCC pin out of your GPIO, and then whatever relay you want to use, they each is denoted by IN1. So if you select IN1, if you connect your GPIO using IN1, then this is the relay you are using, right? So at the same time, you can use 4 relays. Now, the point to note is this is a GPIO side of connection, but relay is a passive device. When I say passive device, that means you can actually use your relay even without connecting it to any microcontroller. It is self-sufficient. Only so for that you need to look at the pinouts here. As you can see this diagram, so this is like this going up and then go back and connect here, and there is another one which is open, right? So there are 3 pins. As you can see, 3 screws, 1, 2, and 3. From left side, how it is called is NC, normally close, common, and normally open. So by default, normally close and common, they are connected. That means if you connect your power supply, and I'll show you that in a demo, right? When we actually go and check the relay physically, and I'll show you how to connect, right? So if you use normally close and common connection, then you do not need any GPIO. It will automatically, it's closed circuit, and power will voltage will follow between these two. But if you want to control your relay using GPIO logic, Then you have to connect your power supply to common and normally open. So based on that, whenever your GPIO pinout goes high or low, whatever logic you have, these common and normally open, they got shorted and voltage start flowing, right? So this is when you want to trigger on demand. We are going to use, most of the time we are going to use common and normally open. By default, if you don't want to use any microcontroller, then you should connect your power supply to normally close and a common, right? So this is about the connection. This side goes to microcontroller, this side goes to motor or power supply, anything. Okay. Schematic diagram. Let's look closely. As you can see, we have 5 volt, we have ground, and then we have the D1, D2, D4 if it is a 4 channel relay, or IN1, IN2, IN4, 3 and 4. 5 volt and ground, they go to respective pinouts on GPIO, and for your IN1 or D1 you can use any of the GPIO input output pin. All right. So this is all about GPIO from our literature. And now what next we are going to do? We are going to inspect the component in our hand and try to make certain connections. And finally, when we make connection, we are going to run a program which will actually trigger the relay, and whatever motor or anything is connected, that will start working. All right, so let's stay tuned. I'm gonna switch my screen and we will inspect the component. Thank you. Let's understand the relay physical components, right? So as I have shown you in Amazon link, this is a 4-channel relay, right? And within 4-channel relay, we have pinouts here, VCC, ground, and 4 pins for your 4 relays, IN1 to IN4, right? So you have all this here. By default, as you can see on the other side, let me see if I can just turn it over. Yes, you can see we have NC, NO, and common in between, right? Right now, how my connection looks like is NC is connected to common. That means this relay right now is working in a passive mode, okay? Passive mode means it doesn't rely on any microcontroller logic, right? And how my connection goes like, as you can see, if you can see, this is a water pump, and from water pump I have this connection which should go directly to this 9-volt battery. But instead of this 9-volt battery, what I'm doing, I have intercepted, or in between I have connected the relay. So the motor positive and negative, and battery positive and negative, they are actually connected to common and normally close, right? So what happened when I just trigger the battery power? So I'm using some this comes within the kit, so you can use this just to control it's like a power button, right? So otherwise, if you use the battery directly, then it will be power on all the time. So we are breaking circuit here intentionally, and this power supply comes as a part of the IoT kit. All right, as soon as I press the button, you can see my motor is running, right? Okay, if I close, my motor is not running, and right now you see I'm not using any GPIO logic, right? There is no lights on. Next, what we are going to do, we are going to flip it normally close to normally open, and then we will see what happened. So now what I'm going to do, I'm going to simply move this to normally open. While I do that, now let's try to power on. You see, circuit is power on, but water pump is not working. Water pump is not working because now it is dependent on the GPIO logic, okay? So let's do one thing, stop the video here. We will start our Python program. It's simple single lead program, like sending a GPU logic high and wait for some time and make it low, and we will see that how the motor will start working. So let's go to our Raspberry Pi. Now we are back with uh, the Raspberry Pi connections. So let's understand the connection here in the schematic diagram. Now I have 5-volt ground and IN1 connected as per the diagram here. So you can see from my uh, relay, I have these connections going to breadboard, and from breadboard, I'm interfacing it to my Raspberry Pi. By now, you are very familiar with GPIO pin connections, so I'm not going into too much into that. All right. So let's look at the program. Program is very simple. It's not even a relay program. It's just what we are trying to do. We are trying to, since I have used pin number 12 for this connection, and I'm calling it LED. Actually, I should have called it like variable relay, but I'm reusing a LED program. So what we are trying to do, we are just making that pin go high, then sleep for 5 seconds, then make the pin low and make again sleep for 1 second. So this is a continuous loop. It's going to run, and as an effect of that, what will happen? And also, you have seen that we have changed the connection. So we have normally open and common connected. And let me power on the battery voltage, battery power supply, right? You see, it's not working because the circuit is connected between common and normally open. So we have to close that, right? And how we are going to close that? We are going to close that using GPIO logic. So let's say Python 3 and the program name, right? As soon as I hit that, you can see motor started, right? And again, it went back, it started. So basically it is on for 5 seconds, off for 1 second, on for 5 seconds, off for 5 seconds, 1 second. See, this is how I can control my motor using relay. And this logic you can very well build in between your project, right? Because you, when you sense something, you want to take certain action. So I hope, let's kill the program first and go back to our discussion. So I hope by now you know what is relay, how to use the relay. Especially this part comes tricky, and I didn't find much documentation on internet also. So if you're not studied electrical engineering, which is, you really don't have to be an electrical engineer, but if you didn't read this subject, right, then I think this video can give you a good pointer on how to make your connection, especially between normally closed and normally open. So I hope you like the video.